Welcome back to the sixth video of the SD-Branch from Scratch video series. My name is Mitchell, and in this video I'll cover the aspects of the configuration of the Aruba via VPN client. Taking a closer look at the current topology, we've deployed two VPN concentrators, VPNC number 1 and VPNC number 2, and the VIA client will make an IPsec connection to one of the two VPNCs. And if IPsec is not permitted or blocked by the upstream router where the VPN client is located, it can also fall back to SSL. So digging a little bit deeper into the VIA client, these are the supported platforms by the VIA client as a software package, or it can be installed through a Play Store. And these are the ports being used by the VIA client. If you want to know more about the latest compatibility information of the VIA client or deployment guides, you will find a link to asp.arubanetworks.com below this video. There are roughly 3 deployment modes which can be used for the VIA client, all ranging from a single VPNC box to a redundant data center to redundant data centers. So figure 16 will be used for a redundant data center with layer 2, active backup VRP being used for that. The VIA clients will share the same IP space across these different VPNCs. But if you would like to have an active-active solution where VIA clients can terminate on any of the two VPNCs, you would use layer 3 separated VPNCs like this. And if you want to make it even more redundant, you'll use a combination of both where there can be obviously also layer 3 separated within the same DC. But over here you'll see VRP being used across both of the VPNCs. And the client can just mix and match and choose to which VPNC cluster it will connect. So focusing on the topology over here, the VIA client will make a primary connection to the via-dc1.sd-branch.nl node, and it will, if this one is not available, it can connect to this particular VPNC. It's important to note that it will make, when downloading the profile, it can go to any of these addresses, and based on that, the VPN profile will include both of the VPNC. So without further ado, let's head over to the configuration part. It's now time to do the configuration on the VPN concentrators to allow VPN clients such as the VIA client to connect to the data center. And for that, we'll do some configuration on the ABC-DC group. But before we do that, I'm going to import the certificates that I'll be using on these VPN concentrators. So I'll head over to the certificates, and I've already imported the root let's encrypt root CA, but I'll also import the via.sd-branch with the subject alternative names via-dc1.sd-branch.nl also to central. So I'll call this via-sd-branch.nl, and it's a PFX file, and this will be the certificate that I'm uploading. All right, that looks to be good. And also another thing that I'll do is I'll upload the file that the clients are using for so the certificate issuer of our private key infrastructure. That will be ClearPass. That particular root certificate I will also upload here as well as a trusted CA. As a PAM, so this is all okay. So now that I've imported these certificates, it's time to allocate them to the devices. And this is something that we'll do on group level as well, since we have our subject alternative names. So we'll do that under the admin settings and under admin authentication options. Here we can define the service certificate that the VIA clients will face. So that will be via-sd-branch.nl. But the certificate will also be used for terminating the VPN IPsec connections as well. So over here, the VIA server certificate, I'll select it, as well as the captive portal. And save the settings. And there's another subject here, certificates for VPN clients. Here I can define which CA has issued the certificates for the VPN clients. And that will be the ClearPass root private key infrastructure. And now that I've defined it over here, I can allocate it from a CA certificate to the serve certificate via .sd-branch.nl. So now that I'm done with the certificates, it's time to do some additional configuration to allow communication for the VIA clients to the VPNCs to download their VIA profile. And in order to do that, I'll head over to Security Policies to find our WAN ACL. So this ACL is linked to the internet links of the VPNCs. And as you can see, port 4500 and 500 are also already defined over here in UDP format. And now I'll also add TCP 443, so HTTPS. So I'll select a service, HTTPS to be permitted. And from this point on, VIA clients can now access these VPNCs to download their certificate, but also if IPsec is not permitted on their location that they are, they can fall back to SSL-VPN. So now that this is configured, I'll create a new interface for the VPN subnet. And this is something that I'm going to do on a group level to at least define it, and then per device, I'll make a device override for the specific IP settings, since we're going to do a layer 3 separated VPN connections. VPN Client -data center and give it the VLAN ID 850. And what important here is to allow routing, which is not checked here, but also to set the force operational status up, because this is a particular VLAN which we're not going to tie or attach to an interface. So if we wouldn't check this option, then the interface would always be down. So we need to check this box, and I'll leave this and head over to the per device to make an override. And this is going to be a /24 Netmask. So please make sure that you size the subnet for your VIA clients appropriate based on the amount of people that are, or devices that are going to connect on this particular network. So save these settings, and I'll do the same for VPNC number 2. All right, now that this is all done, I'll head over to the generic VPN settings to allow VIA communication. So head over to the group settings, since these settings will be the same for both VPNCs. So under VPN and then general VPN, we can define an address pool, which is something that we're going to do an override on per device as well. So these were the subnets that we've just created. And define this as ClientVPN. And this is this can be just a bogus IP address. Enable VIA SSL fallback, and let's define our primary corporate DNS server. And save these settings. All right, now that it is configured, we can override it on the devices. And this IP address will be the subnet or network that we've just configured. And So the VPN clients will receive an IP address from this specific pool. So this is the IP address for VPNC number 1 or the pool, and then we'll do the same for VPNC number 2. All right, now that we've configured the pools and the interfaces, we can focus on configuring the VIA VPN settings. And before doing that, because we're going to authenticate these particular clients, and we'll use ClearPass for that. So I'm not going to really dig into the configuration that is needed for ClearPass to get started, but we'll use a username and password to authenticate these VPN clients. And in order to authenticate these clients, or at least send the authentication to ClearPass, we need to define an authentication server. So here I'll define ClearPass and also add it as a change of authorization server. So now that these servers are created, it's time to add it into a server group, which then can be referred to in a AAA profile. So I'll just call this ClearPass Policy Manager, and then we can add the Radius server. And these server groups can then be used for Radius authentication, but also accounting as well. So now these server objects are linked into a server group. All right. Now it's time to head over to layer 3 authentication, where all the VIA profiles reside. We have 3 VIA VPN configurations over here for the authentication. So this will determine where the authentication requests will be sent from the VPN client. The connection profile is used with basically determining whether, for example, you would like to route full tunnel or split tunnel the client's traffic. And then this will be the VIA web authentication profile is used for the first time when a client tries to download their profile. So we'll first start with the authentication profile, link that to the web authentication, and then in the VIA connection profile, we can link that to the VIA authentication profile. So starting with the VIA authentication profile, making a new one. I'm going to use the default role here to check to really check the certificate name, and the authentication protocol will be MSCHAP v2. Please note that you also have the possibility to use a client certificate to download the profile, and you would need to add port 8085 in order to use a certificate to download this. But for now, I'm just going to use a username and password based on AD credentials. So save these settings. And after this profile is created, we can click on it and then add the server group that we've just created. So there'll be ClearPass Policy Manager over here for the accounting of Radius, but also the change of authorization server. Over here, add that. Oh, we do need to save that. And add the server group as well. So now that we have defined our server group into our authentication profile, it's time to refer this authentication profile in the web authentication. So there's just one profile, you can't really make any other ones. And here we'll link the authentication profiles. So you could make an authentication profile for certificate authentication, for example, and or username password. So now that these two profiles are linked to one another, we can create a connection profile. I'll call this SD-Branch con profile. And here we define the VIA servers. with the external address, so that'll be via-dc1.sd-branch.nl, and I'll call this data center 1. And the internal IP address is the IP address that we've also used for the micro branch as well. So this is the loopback or the switch controller IP address that Central has given out to the VPNCs, and here I'm just going to copy these IP addresses, save it, and then add the second VPNC as well. So this means that a VPN client can select based on its preference or override a setting to a particular data center. And if DC1 is not present or available, then the client will automatically select the second entry. All right. Well, there are a few things that we need to configure here. For one, for as well the authentication profile. So the one that we've just created. The tunnel network will be, so I'm going to enable split tunneling and only tunnel the data center server network. So there will be 10.19.100/24. Use default policies here. Enable IKv2, and I'll be using username and password, so there'll be eep-mschap-v2 with the default IKv2 crypto maps. And I'm just scrolling down these settings. I'm not going to change the settings over here. All right, so this all looks good. I'm going to save these settings, and now that we've added this connection profile, it's time to tie that particular connection profile to the role. So I've mentioned that we're going to use the default VIA role, and here under more, we can define the IP address space that these particular clients are going to receive. So there'll be ClientVPN. And the connection profile is going to be SD-Branch _ connection profile. There is also, of course, the routing. So currently we are redistributing our connected interfaces into the BGP autonomous system. So if we take a look at redistribute, we are already redistributing our connected interfaces. So this means that based on what we've configured thus far, the communication for our VPN client should automatically work already. All right, it's good to mention that I'm already connected to the lab network, and I've already installed the Aruba VIA VPN client. So head over to via-dc1.sd-branch.nl. But this can also be via-dc2.sd-branch.nl, for example. And I'll fill in my username and password. And download the VPN profile, like so. It'll ask me to allow and add this certificate to allow the VPN configuration. And now, as you can see, it is split tunnel, and I'm now connected with the VPNC number 1, the IP address that we saw here, eep-mschap-v2. And here I can also select, for example, that I want to connect to the second data center. So I would have to disconnect and then change the server. But let's try and see if I can now connect to the corporate server. Let's see if I can now go to the corporate web server. So there'll be 10.19.100.2, and sure enough, I can now access this web server. So let's take a look at the communication on the VPNC to verify that we are actually connected with our VPN client. So filter, yeah, you can already see it over here. So 10.80.50.15.2 over here. This looks to be good, a web application going from this particular client. So this is really nice. In the next release of Aruba Central, it will also be possible to see the VIA VPN clients in the client overview, as you would see with a wired and a wireless client. For now, just to verify and to show you that we have our client connected, I'll do a show user table, and you would see that this particular client is logged in as Mitchell with a default VIA role. And you can see some additional details over here. Of the sessions and what kind of device it is connected as. So this information will also be available in the next release, Central 252, and you would see this particular information under clients over here. And that's a wrap. This was the 6th video of the SD-Branch from Scratch video series. In this video, we covered the different design options of a VIA deployment, the configuration of it, and validating the configuration with a VIA client with the use of an iPhone. In the next video, we'll go back to the initial branch location with the 9004 gateway and configure some additional networks and configure the appropriate firewall rules for them. Per usual, I hope you found this video informative. If you want to receive any updates and would like to see more of these videos, like and subscribe, and feel free to leave any questions or comments below this video.